Okay, so here's what we're going to talk about today. It's going to be percent yield. Okay, now the formula for percent yield equals the actual divided by the theoretical times 100%. So what this is whenever we have these problems with us, what we're doing is we're trying to find the actual yield and the theoretical yield. This one, the actual yield, will be given or you find out. Now what do I mean by that? In your lab, in labs that you do, you find an actual yield. That's what actually happens when we run through the procedure. The theoretical yield comes from a gram to gram conversion. Okay? So whenever I say it's given, if you see here, it says you obtained 12.1 grams. That right there, well, that was a little off. There we go. That right there is your actual. Okay? So what we need to do to figure out the percent yield is figure out the theoretical. So that's what we're going to do with this problem. So we have our equation, this guy right here. Now we're going to do a gram-to-gram problem. So we're going to start with grams of phosphorus, and we're obtaining grams of P2O5. So that's what we do. We set our equation up, grams of phosphorus, and if it's a gram-to-gram problem, how many steps is that? 3. So it's grams of phosphorus to grams of P2O5. And you start with 5.00 grams of phosphorus. Okay, so we put the molar mass, which is 30.97 grams of phosphorus. What do we put on top? 1 mole of phosphorus. Now, what do we put down here, generally? Mole of what? Phosphorus. And then what do we put on top? Of diphosphorus pentoxide. All right, now what do we put for the numbers right there? 1, 4, 1, really? Yeah, it should be 2. Okay, so you put 1 mole P2O5 over here, and then what do we put right here? The what? Molar mass. What's the molar mass of P2O5? 141 point what? 96. Very good. So, multiply through, divide by the bottom, tell me what you get. So you get 11.4-ish grams of P2O5. So this right here, theoretically, this is what we should get, 11.4 grams of P2O5. But what we actually got in the problem was 12.1 grams. That's okay. So we do our percent yield equals our actual, which is 12.5, divided by 11.4 times 100%. So notice it's grams on top, grams on bottom. We cancel out both the grams, and we're left with the percentage. Okay, so somebody do that. Tell me what you get. What, 110? 109? Okay, so where did I get 12 point, or sorry, so why did I put 12.5 when I should put 12.1? It's fine, we got 12.5 down here. Alright, so if you put 12.5, okay, that's what you should have put in your calculator.
I got 109 though.
You got 109?
I got 109.
109.6, right?
Yep.
So it's 109.6%. And that's your answer. So whenever I ask you what's the percent yield, that's what you're going to put. No, just 109.6%. Okay, because it's telling me what that yield is. Alright? So go ahead and try that problem. Alright, so what are we starting with in this problem? Of what? Na. What do we need to find over here? Grams of H2. Okay, so how many steps am I going to do? 3. So 1, 2, 3. What do I put down here?
22.99.
And that's the what of, that's the molar mass of Na. What do I put on top?
1 mole.
What do I put on bottom right over here?
2
2
Na.
mole
Yeah, 2 mole.
Na. And what do I put on top?
1 mole.
What do I put on bottom?
1 mole.
And what do I put on top? Okay, so what do I end up getting with this problem? So is this my actual or my theoretical yield? Theoretical, okay, grams H2. So I plug it into my equation, percent yield equals my actual divided by my theoretical times 100%. So that equals, what's my actual yield that I obtained? 503 grams H2. And what's my theoretical yield? Okay. Times what? 100%. Alright, what do we get on, what's our percent yield? 71.656. What does what say? A divided by 2 times 100%. Alright, so you get 71.6%. And that's what we're going on. Okay? Questions on that stuff right now? Everybody good? Alright.